So, by nature, systems are distributed. So, distributed platforms, so whenever you imagine any steel plant or any industry manufacturing units, so most often the actuator sensors are situated somewhere else, and there is a central processing unit or the one control room where all the things are sensed and controlled. So, most often we can think of a um, SCADA and DCS kind of systems. So SCADA, whatever the example quoted in the first chapter, if you can recollect, supervisory control and data acquisition, and DCS distributed control system. That's how the normal scenario for systems working with respect to geographically separated stuffs. So inherently they're distributed. Data sources are at different locations. So I have sensors and actuators. That's how the uh, system seems to be distributed with geographical area as such. Cost effective because whenever you want to bring everything onto tabletop or one room systems, it may not be feasible or possible. And even if you are able to do it, then maintainability of such a system is at stake. So, if you are imagining writing a monolithic code kind of stuff, so you are writing somewhere around 10,000 lines of code, and for a possible functionality, whenever something is going wrong, it's very difficult to point out that particular error depending on the logical sequences as such. So, if you are designing modular approach, so then there can be some number of models are failing, and there is one root cause, and the convergence can be traced back, and that can be detected or debugged. So DRTS stands for Distributed Real-Time Systems, requires it to support real-time communications. Now we don't know exactly what is meant by real-time communication, but we want to know what is meant by real-time communication. If you can imagine two scenarios of communication, so that you can identify what is really meant by real-time communication as such. You are sending and receiving mails, right? So that textual communications. So then compare it with respect to the WhatsApp call or Skype call, whatever the communication you are doing through the VoIP or voice over internet protocols. What do you expect? Any answers? Email communications or the FTP protocol, file transfer protocol communication protocol, or VoIP. So what is the difference? Okay then, ಹೇಳೋದಿಲ್ಲ ಅಂದ್ರೆ ನಾ ಹೇಳಬೇಕಾಗ್ತದೆ. So email, they are not time bounded. You send it, and whenever that particular server is free, and then it goes and sits wherever your the targeted destination address is there, and whenever he is feasible, he reads it. Fine. So real-time communication is most often if two individuals are communicating, again, average persistence of hearing is normally stated as 1 by 10th of a second. So that whenever I say hello or how are you, some statement is uttered that has to reach that person. So the overlapping of sounds or phonetic notes as such, they have to be overlapped so that there is a continuity as such. If there is a larger break, maybe due to your processing algorithms, because you are digitizing and then making compression, and because of the limited bandwidth, you are sending it onto the network and it is reaching the other end. If either through network delay or processing delay by somehow means you are exceeding 1 by 10th of a second, so then there is a most of idle periods, or I'm not saying the reception is intact, so data is received, but the data reception may be having more delay than the 1 by 10th of a second or persistence of hearing. ಅದಕ್ಕಿಂತ ಜಾಸ್ತಿ ತಗೊಳ್ತಾರೆ. So the communication is more disturbing rather than communicating or conveying any information or idea, because uh, it makes the persons annoyed, and unnecessarily you start repeating the same information, hello hello hello, nothing beyond that. So finally the communication, somebody has to put an end to it. Ultimately what I want to convey is that 1 by 10th of a second, or the information has to reach with all the communication network or backbone, whatever the how you are connected, my landline, then through internet protocol, or through your telephone trunk and exchange, and finally so whatever the means, so circuit switch, packet switch, sonet, continental fibers, or the satellite phone. You imagine anything that has a boundary, or the you should promise me that for voice communication the things will reach within a 1/10th of a second, and there is a continuity, and that's how the some things have to be promised. If you can say what is it, interact, we can communicate better. Otherwise it's monotonous. I just go on reading whatever the in the slides. Fine. So traditional versus real-time communication. Traditional communication networks provide best effort service. What is meant by best effort service? So whatever is produced at a transmitter end or production end has to reach the other end. So receiver end with again with minimum cost. So you want to travel minimum distance, shortest path, or whatever the algorithms with respect to your network layer and other layers. So make sure that with minimum cost you are able to reach the other end. In contrast, real-time communication network supports specific quality of service. It is as good as in quantifying the definitions of real-time with respect to functionality. We stated that the timing is as much important as functionality. Now, with respect to communication, so reaching the other end within a stipulated amount of time is as important as reaching intact, or the packet should not be lost, or the bit integrity, or the signal integrity should not be lost. Whatever you want, information integrity is still prevalent. It is there. So whatever you packed and sent, that has reaching the in the same aspect at the receiver end, as well as it is reaching well within the time. So it is not tampered in between. That's what is should be promised whenever you are stating quality of services. So what are the aspect of quality, or the QoS, quality of service, whenever you are paying any service provider for that matter? So you promise that particular quality of service. Maximum permissible delay. So even though uh, we may not be directly involved in this aspect, but indirectly, whenever I'm taking Airtel, Vodafone, whatever the communication as say with respect to voice oriented communications, or CFI, BSNL, Geo Fiber, anything, any communication service you are interacting. So most often you may checking start from the user's perspective or layman's perspective. I should be able to play an online game with 5 of my friends. That is my requirement, and it should appear more realistic. It should not be something like I shoot it some, and maybe after 1 second or 2 seconds I hear the firing sound of a bullet, or that person is moved, or his actuations are not intact. So virtually we are playing, and it should appear that all are happening simultaneously in spite of all the network delays as such. So indirectly we start speaking about maximum permissible delay or maximum loss rate with respect to application. I'm stating, say, video gaming aspect ಅನ್ನೋದು ಉಂಟು. So that's how you start analyzing. So maximum loss rate. So if you are viewing any YouTube video, or there is a buffering, or there are some frames lost, or some packets lost, so how much loss is sustainable? Still, there is a pleasantness in viewing a movie whenever you use that service as such. In real-time communication, once the network accepts a connection request, it guarantees the requested service quality. So before negotiation, or in the negotiation, so there are two parties. One is the service provider and the service extractor. So if I am applying for GeoFiber or any communication standards, so I have some aspects. So he promises me 100 Mbps or 3300 GBs per month. Some terminologies will be popping up, so that we agree upon that. So almost always average speed is 100 Mbps. If he is rating 100 Mbps, if it's not 100 Mbps, it is 40 Mbps. So worst case, best case. So you have some scenarios with which you can argue with respect to that service providers. Once he accept that, he is liable for that. So you are promising something because you are accepting money for that. So in payment ಮಾಡಿದ್ಮೇಲೆ, then you are legally have the rights. So if service is not, or somebody is violating SLA ಅಂತ ಹೇಳ್ತಿರುತ್ತೆ, service level agreements, so then the other person who is extracting services may sue the other person in the court. So once you are agreeing real-time communications, that has to comply that. So service quality, whatever is promised, maximum bandwidth, minimum permissible delay, whatever we have discussed, or there are some certain parameters with which that qualities of service agreement is prepared, and both parties have agreed upon that. Now, what are the defined terms in few QoS parameters? Bandwidth. So always 100 Mbps or 200 Mbps, whatever the data rate you or bandwidth, yeah, the service provider has promised, that should be made available. So with which it is one of the criteria for the quality of service for which you are arguing. Maximum transmission delay, because in the network we don't know how the packets are being routed and how they reach their the other end. So if I'm making Skype call, I'm least bothered whether my packet is taking what is it, Sonet optical fiber or the continental optical fiber, or it is reaching the other party through satellite. They both have the different delays, but what is the maximum, or the within which time you say that your packet reaches in no matter, or in whatever the way it travels. So somewhere you have to state about what is the worst kind of scenarios or situations. Delay jitters, so we accept it, but maybe there are some deviations with respect to arrival rate or the of the packets. So some acceptable norms or margins which are to be specified, so that it helps in the synchronization of the other processes in the system as such. Loss rate, so it is as good as you once you start attending your communication classes, what is a bit error rate. So now later part I'm coming to the application layer, what are the packet losses and so on. So there is some loss rate whenever the communication happens with respect to channel and other aspects. So how much is sustainable, are there any mechanisms to deal with respect to that? That is up to the system design as such. But whenever you are promising, so most of it is at marketing level. How you implement, yes, engineer's job. Blocking probability, so normally whenever I purchase him, so it gives me right to call anybody at any point of time and save 300 or whatever the amount you have recharged. So duration of the call is free, but normally if you imagine a scenario, how much times you are blocked. So most oftenly there is a traffic variation, hence and you may be blocked at certain times in certain areas. Every cell phone has a limit. Say one base station may be having the criteria, say at any given point of time it can serve 300 people. Fine. On base station, so there are 300 frequencies that can be allocated to your cell phones. But sometimes it may happen that maybe one celebrity is coming to that particular area, and there's a gather of so many people, and within that one base station we cannot serve all the people in that particular cell or area. And hence whenever you attempt to call in that particular mode, whenever simultaneously many callers are attempting to make a calls, so you are blocked or you are not able to connect at that moment because of the inability of that infrastructure as such. So that is occasional and could be understood. If you can imagine that happens every day because you are residing somewhere near to any Kalyan or where normally gatherings are happening for a large number of people, and there is only one base station. If you can, your house is near to that. Now, think from the perspective of blocking probability. There is a larger blocking probability only with respect to the problem is the user. It may not happen to the 100 people of or 100 my neighbors, but only to me. And how do I address it? So that's where you start arguing or complaining with respect to. But you said something and it is happening something else. So these are the parameters or the quality of parameters. These are example quality of service parameters as such. So there can be many other as well. Okay. We classified applications into hard, soft, firm, real-time system based on their task characteristics. But that may not be very realistic to map the same stuff with respect to communication aspect. Um, we shall so there is only classification. It's a real-time and it's not real-time. So if something like a voice-oriented or the whenever the live streaming kind of stuff, video or the audio kind of stuff, then you may say that that is more real-time communications. If you are going for a online conferencing kind of stuff, if it is not that, then it is not real time. So any mail transactions or anything running not so much time critical, or it is not interacting with humans, it can do off the track as such. So then it may run. So I am not firm on any of my wordings as such. onto the non or soft real-time communications. Okay, 1 minute. So few quality of service parameters will be still there, or service level agreements will be still there, and maybe the list is reduced, insensitive to others. Examples of soft real-time communication is file transfer protocol. So if you are sending one file, it has to reach that the other end. That is what is expected, depending on the bandwidth. So if it is already morning 8 o'clock, nobody is there, and you can utilize full bandwidth. So it may happen within a fraction of seconds. So maybe in the 12 o'clock there is a choking because everybody has logged in. The students are also allowed to log in our college, and administration block is already logged into 10 o'clock. So now there is a traffic and bandwidth sharing happens, and now the same file transfer may take a larger duration. But what is important over here is file transfer or best effort. So whatever you transfer is reaching the other end, but the time duration is not critical. So email or web browsing, so they can have their own basically functional unity or the communication unity. So you are sending email and the mail is being read or sent. You are transferring a file is transferred. That's how it is evaluated with respect to soft real-time systems. If I start stating that this has to be transferred within 10 seconds or 10 milliseconds, then you are into a real-time communication. So you are imposing some permissible delays for the communication aspects as well, or the quality of service aspects as well. Loss free operation in FTP, loss of even a small part can make an entire document unusable. That is as good as stating you are downloading something 99% error free, and last minute maybe the power cut off, and you have to repeat entire process again, unless you are downloading with a download accelerator or download manager kind of software. Most often that the connection is lost, and you have to re-attempt the downloading of a particular file, because of even one byte or the one bit is missing, that entire file is not usable. So maybe that is preserving some important information for that matter. Much of the complexity of traditional network protocols arises from the need for loss-free communications. So normally whenever you start studying digital communications, it is a bit error rate kind of stuff, or the packet loss, so with which you start evaluating a system as such. But later part bounds of the real time, you also start worrying about the timing. So average packet delay, average throughput. So some nomenclature, whenever you say that we are negotiable, but negotiable up to certain limit, right? So that's where the bounds on average packet delay or average throughput are to be decided and to be agreed, even in the non-real-time communications or soft real-time communications. Parameters that are not important: worst case packet delay, jitter, and worst case throughput, that are not required for soft real-time communications. If you are considering real-time communications, they are there because they are oriented towards the best efforts. So whatever transmitter has transmitted has to reach the other end intact. That's their job. Fine. Non-interactive in television and audio broadcast requires stringent bounds on jitter, but rather insensitive to delay. So this speaks about if there is a variation in the um, arrival times of the frames or the packets as such. So you may start seeing some glitches or some blocks into your screens. So with respect to television, so one aspect may be important than the other aspect. So jitter and delay, if you are considering. So stringent bounds on the jitter, but delays, yes, some flexibility is there. Real-time communications sensitive today. Sensors data processing in a fly-by-wire aircraft. So he's quoting a scenario. Fly-by-wire is, assume you are flying a plane which is moving at some, or a missile, if you can think of to just to quote that fly-by-wire or aircraft or corrections. You are moving somewhere near to the supersonic speeds kind of stuff, then for the direction corrections and other stuffs, you are having somewhere around some milliseconds of timing, so that you are still into the correct trajectory. Otherwise you may move out of the trajectory and land somewhere else. So it is very sensitive to delay. So how do you communicate and how do you rectify the things become very prominent to keep the things. If you are flying a plane, fly by wire. So it's, or you are have fired a missile and the trajectory correction has to happen within a stipulated amount of time because it's flying at a very high speed. And now I've computed a new trajectory and that reaches by certain amount of time already the path is over or the correction cannot be done. So there is no hope for the system. Something of that sort has happened. In those kind of scenarios, imagine they are sensitive to delays, so that within a stipulated amount of time the things should reach there, and then the further computation and other things, there should be some margin so that there is still hope for a system or rectification. Only sub-millisecond delays in receipt of sensor signals is acceptable to the controller. Okay, that's what is it. Firm real-time applications, multimedia applications. So multimedia applications are not affected by much by delay, affected by jitter and loss rate. So there can be video transmission sensitive to packet loss, shows up as flickers or glitches on the screen. So one or two, even sometimes frames are missed. Um, the user may not notice until unless there is a larger information content in that particular frame. Again, depends upon the coding architecture of that MPEG or whatever the codec they are being used. So how do you should imagine is, unless if you are watching something like Ramayana, suddenly from yeah, okay, Ayodhya Kanda to Sundarkand, if you are shifting that something in the palace to something in the forest, so then there is a larger information change in the background. Otherwise, Rama, Sita, or whatever normal characteristics will be same. So if there is a larger information change in the contents from one frame to another frame, then user is normally able to notice. If the same scene or the one or two frames are missing in that particular scene, say 33 frames per second or 35 frames per second you are running, that is seen as a video, and few frames missing may not be perceived by the user unless there is a larger information content. So even if whenever the packets are missing, some flickers or glitches can be seen onto the screen, and hence it is firm. So some failure is yes acceptable or marginal. Voice applications, the quality of voice degrades rapidly with loss rate and jitter. So you are not able to hear what the other person is saying. So maybe that creates annoying effect. So that's where you again fix up the margin so that this is acceptable. There are packet losses, but still hello is being heard as a something near to hello. It's makes sense. And jitter, so arrival rates of the packets, so then it may fail to synchronize the things, and with respect to bit rates, whatever your constant or variable bit rates ಆದಾಗ then the communication is hampered or annoying. So and hence firm andre some of the components or some of the packets are in loss, still the system is able to sustain that loss. So whenever I'm attempting that generic word as some or how, so that depends upon what is the application you are delivering and how much is really sacrificable as such. So examples of applications requiring real-time communications. So manufacturing and automation. So most oftenly, if you can imagine any iron furnace and within some 10 milliseconds or 10 seconds, so the furnace is reaching 1500 degrees centigrade and heater should be turned off immediately whenever you note that thermistor sense 1500 degrees centigrade, otherwise the furnace may blast. So whenever I'm making that quantification of time, so you should be working in that industry, then you can quote that realistic more timings with respect to that, whether it's 10 seconds or 10 milliseconds. Basically what is important for me is that there is a fixed time for that within which the things should happen. Okay, so automation in the chemical factory, similar kind of stuff. So there are sensors and there is some action to be taken out of that sensors values as such. Internet banking applications, so think of a perspective that somebody is depositing, somebody is withdrawing, and with same account that is happening, how do you make sequencing of the things? So depositions, so real-time communication, it may not be in terms of milliseconds that may be happening, but how do you resolve the issues if simultaneous deposits and simultaneous withdrawals are happening? So what should be their account balance shown? So my father is depositing 10,000, and instantly, at the same instant, unknowingly, I'm retrieving something 5,000 from my ATM. Now, what is my balance, or how much it should showcase? So they are normally resolved at algorithmic levels. So maybe deposits are given a higher priority compared to the withdrawals, and that's how the things are maintained as such. But ultimately, they are bounded by time. So that is what is to be taken care whenever real-time communications or real-time applications are to be done. Video conferencing, as we have stated, there are certain frames that are maybe missed out, but voice is more sensitive to delays and jitters compared to the video. Yes, video also has that aspect, but it is much sustainable compared to the audio, as I stated. Multimedia multicast, whether video conferencing or multicasting, as we are stating that. So whatever I'm uttering, it is reaching the some number of nodes or simultaneously. That is multicast. Internet telephony is again whatever your Gtalk or Skype, voice over internet protocols. So that's where you are sending the things as a packets, and packets may routed through virtual network as such. And hence the arrival of the packets and reassembling them, and then again whatever the voice layers and ISO layers you have studied, so that has to travel through all that within a stipulated amount of time, and then serve some application layer, so that the communication is intact. Example showcased, and if you can imagine certain stuff, so synchronicity has to be maintained with respect to this moving robot, or the there is a central control system, so depicted by the computer, and maybe 3D arm that is showcased over there doing some job. So how do you effectively synchronize with the movements of different angles x, y, z, and holding of an object, or soldering, or welding, whatever the operation that particular arm is doing? So there should be proper synchronization that has to be maintained with the conveyor belt as well as that particular robot, and hence the communication or real-time communication is important. So we quoted Vivo IP repetitively, or the Skype calls and other stuffs. So they are happening through IP routers. So voice packet is as good as any other packet, and normally the packets can reach out of order, and they have to be organized, and then they have to be addressed. So in that scenario, so there is a separate server called as a diff server, which looks to the incoming packets if they are having a higher priority. So they are going out of line, so jump the line. So otherwise you are put in a queue. So normally first come first serve basis. So all the packets whatever is arriving to particular switch, gateway, hub, ಯಾವುದೋ ಒಂದು network node ಬಂದಾಗ, so then they are served in a queue as such. Whenever you see a packet which has arrived, which is having that what is it, some priority number or some information, so some flag set onto that, it is very much important. It is as good as any fire brigade or ambulance kind of a packet. So you should make a lane for that, readily transfer, so that goes out of lane or the jump the line and transmitted ahead of other packets. So that is taken care with respect to flag observations by the node operators or the network operators in the sense, so your switch, hub, gateway, router, whatever you can imagine. This can work well when voice is a small fraction of the total network load, as it is today's internet. That's stated. Delay consists of three components: propagation, transmission, and queuing. So propagation delay, it is with respect to physical reality, you are either using a copper wire or optical fiber within which the signal made a transition from 0 to 1 or 1 to 0, and the same is replicated at the other end due to some RC component. If I am saying copper wire antandre, there is some RC delay or is introduced after toe that is visible at the other end. So with respect to that, if he is expressing it 5 microseconds per kilometer, so there is a delay expressed for per kilometer of that wire. So 5 microsecond delay is added to your packet for with respect to session. Packet size divided by the link speed. Then you are stating the bandwidth. So how much speed with which you are reaching the other end. So that is our transmission delay. Packet size divided by, so how much actually each bit is taking to reach the other end. Queuing delays normally happens with respect to the um, uh, network nodes again, maybe buffers or switches, so switches or hubs or gateways may be having some buffers, because there will be data rate mismatches between the connections as such. So whenever there is a burst of data, normally it is buffered, and then it is forwarded as and when the link is free of congestion, and you can proceed further. So depending on the traffic, the queuing delays will also incur with respect to that packet. So these will be three components that are contributing to the delay aspect or delay element. So maximum variation in a packet delay in a packet switched networks, jitter increases with load due to queuing delay. So queuing is happening because of traffic jam. If I say that I have to reach a Jubilee Circle, and what is the average? So depends upon the traffic at Gandhinagar, Vidyagiri, and whatever the junctions and loads, or when there are congestions. So that common road or common lane which is shared across different aspects of the different nodes of the network, and hence whenever there is a jitter because of arrival time with respect to that node, so particular node ಬರಬೇಕಾದ್ರೆ ಅಥವಾ node ಇಂದ ಬಿಡಬೇಕಾದ್ರೆ, that is what is meant by jitter, and that adds to your queuing delay. So how much time you are spending in the queue or buffer, so, or traffic signals, so that is your jitter. uh, Packets may take different paths. So how do you reach the other end? May be varying because of your traveling through virtual network. It is not a circuit switch network, it is a packet switch network, and every packet travels differently. So destination is same, but the path is different, and hence the arrival times or the exit times are different, and hence they add to jitter as such. Buffer at receiver end can reduce the effect of delay. Uh, I don't really quite agree with this buffer at the other receiver end. So once it is reaching the other end, then how it is processed has to be maintained, because of it is a job of transport layer. Maybe somebody has reached early, somebody has reached late. You have to reorganize so that the packets received makes a sense, and that may happen at a receiver end, and hence the buffer is required for that. I have no ambiguity with respect to that. Okay. Buffer size required to reduce jitter. The buffer required at the receiver end to reduce jitter peak rate, so into a delay jitter. So peak rate is what is the maximum traffic that can occur at any moment of times, and what is the delay, so that so many people have to be accommodated. So video source, he states, or one example just to note. Please read it. So every second you are transmitting, because it's a video 30 frames per second. Each frame contains 2 MB of data. So 30 into 2. So then jitter is 5 seconds. So there can be difference in the arrival rates. If at all some packets have arrived already, so they may be made to wait for 5 seconds, and that is what is the buffer size or bucket size you have to have, so that you can accommodate whatever they have arrived. ಅಂದರೆ so maybe 5 ಸೆಕೆಂಡ್ಗಿಂತ ಹಿಂದಿಂದು ಮತ್ತು current everything occurs simultaneously, and whenever they arrive, so you have sufficient space to accommodate that particular data, so that nothing is being lost. That is what is the meaning as such. Bandwidth. The delay is experienced is proportional to inverse of the bandwidth. Normally latency and bandwidth are somewhere related. Latency again go with the term as delay. Inverse of the bandwidth. An internet is it is only partially to larger part of the delay is due to the queuing delay that is happening at different node queues. Losses may arise due to the various reasons. Delay bound variation. So after certain amount of delay that even that arrives, that may not be useful. Delay jitter bound variation, again, that may not be useful. There is a overflow kind of stuff. Then data corruption. So yes, maybe lightning or somebody has started a motor or mixer that has corrupted some of the bits, and the data is no more useful, or the packet is no more useful. So the chances are there, and that adds to your loss rate. So if somebody is rectifying the stuff, so he has to look into these aspects, and If something can be done to that particular aspect which is increasing the loss rate, that has to be done. So blocking probability, as we have stated, blocking may arise due to the various reasons. So a caller may be rejected under high load conditions or due to want of resources. That's what I quoted. A celebrity arrives, and normally a base transmission station is having capabilities of 300 calls, so with the, including the other uh, caller and callee as kind of stuff. So if at all there are more people and simultaneously all of them wants to make a call, then normally call will not be connected. That is what is called as a blocking probability. Even in network scenarios, maybe something if you can imagine, Amazon Big Billion Day or Flipkart Mahamela kind of stuffs. So 12 o'clock or there is some time or some mobile handset has been released and you want to book it. So simultaneously some lakhs of people are trying together, and simultaneously some 10,000 or and odd people will be blocked due to that. Maybe because that is a network or that particular server is designed to handle only restricted number of users because of bandwidth criteria, and hence you may be blocked due to that. If that increases, it is as good as stating you are not able to, or that particular company is not able to manage its success. So we advertised Amazon Big Billion Day, and whenever millions or billions of people are trying to purchase or make transactions which will yield for your profits, but because you have chosen a lesser bandwidth, most of the customers are dissatisfied customers. That means they may not try your option next time. So first success, you are unable to manage success, which turns out to be failure in the next attempt. So that's where blocking and other things have to be done. So there is a success management and failure management in both the scenarios, whether you take it individually or system design. Some mechanism has to be made or dealt. Okay, then we are moving to next. So is trying to address different aspects of communication system as such. Now, the traffics are regarded as three kinds of traffics is dividing the real-time traffic. One is a constant bitrate traffic, another is a variable bitrate traffic, and the third one is sporadic. So randomly, there's a large amounts of silence between any two communications. They are regarded as a sporadic traffic as such. So, looking one after another, CBR traffic arises due to the constant bit rate of data generated by a source. So, assume there is a sensor, and you have programmed the sensor in such a manner for the every 30 seconds or every 10 seconds it has to sample the environment and sense whatever the data it has captured onto the network. So that is periodicity. So for every 10 seconds or 30 seconds, whatever the periodicity you have set, so it is that because that sensor data is maybe 8 bit or what are the number of on the other size of the, so that amount. So almost it's equal amount of data is being transmitted in with equal intervals of time. Fixed sizes message transmitted periodically. That is what is meant by CBR, constant bitrate traffic. So normally generated by hard real-time applications. So sensor data in the other. Next is VBR traffic. VBR is variable traffic or variable bitrate traffic. Different rates at data transmissions at different times. So one is the amount of data is different at different instances of time. Fine. So you see that pink pillars and purple, green or blue. So the amounts of data transmitted at different instances of time are different. They are not fixed and hence variable. Or there can be larger gaps of silence kind of stuff. So the gaps between any two transmissions is variable. So both add to variable traffic. So he also gives the example of this example. Here the data it is being transmitted is fixed of fixed size, but there is a silence between any two transmissions. There is no fixed amount of time. There is no periodicity with respect to the transmissions as such. Even then, that comes out to be in the VBR traffic. Uh, Larger idle period or silent periods. Yeah, just I will just animate this slide. So compressed audio signals generated from a speech signals. So there is the audio compression, and normally that amounts for the same amount of data. He just wants to explain that same amount of data with variable silence periods. To reduce the size of voice traffic, no data is generated during the periods of silence, and this results on-off of sources. So fixed size of data is generated during on periods, and no data is generated during silence periods. That's what is so fixed size with the variable silence periods or the idle periods. One example for VBR. So with respect to that aspect, even sporadic traffic is a special class of what is that VBR as such. So you can say that packets are generated in bursts, followed by normally the periods of silence are longer in sporadic traffic. So longer has to be made in comparison with something. So burst data, so there is a sudden rush of data and there is a larger period of silence. So amount of activity and amount of silence with which you can build a ratio, and normally that can be used as a to quantify something as a sporadic. If you want to make an attempt to give a definitions for sporadic traffic. So sporadic is special kind of VBR traffic or the variable bitrate traffic. So sudden peak outburst, and then there are largest amounts of silence. ಜಾಸ್ತಿ ಇರಬೇಕಾಗಿತ್ತು. So usually called alarm avalanche. Alarm avalanche is basically whenever a fire and other accidents happen. So there is a sudden rush of messages to all this. Maybe to the sprinklers, you have to inform the fire brigade and the, announce something to evacuate the arena to the employees or whoever is occupants. So suddenly there is a avalanche or the large set of information is being transmitted. Otherwise, if there is no incident of fire, normally there is a large period of silence, or that system is never, it looks like as if never working kind of stuff. Choice of network for real-time applications. Many real-time applications geographically spread out or consistent of components located on in an enclosure, so they can be of any kind. Automated manufacturing system, high-speed data acquisition systems. So again, examples for that. Network choice for real-time applications. LANs are now automatic choice for networking. So by dedicated point-to-point links, circuit switching are inefficient and costly. Can anybody elaborate upon circuit switching and packet switching before we go to next slide, so that I can explain what is inefficiency and costly kind of affairs? Anyone? So how many people are there now? 14. Fine. Okay then. Assuming that you don't know that, I just repeat that. Circuit switching is normally you establish a circuit, then the traffic flows through the circuit, and then you disconnect the circuit. It is as good as any PSTN, public switch telephone network, you are seeing. So there is a subscriber, he's allocated some numbers, then you get connected to some local exchange to some trunk, and another local exchange, so main exchange to another exchange, and finally to the other person's local exchange, and finally to the subscriber whom you are calling. Whenever you are dialing a number, so you are establishing a circuit. So my telephone to my local exchange to main exchange. If there somebody switches, if you are imagining something, some kind of films or any other films, age old, so a trunk call. So whenever you imagine, you just see the people plugging in some aspect over there. So call to Bombay means there is a particular switch where you plug your wire so that you are connected through that particular plug now, or you are establishing a circuit. And later part there was a Stauger switch. There is a automation mechanism. Now people are having a digital muxes for that matter, where you are establishing a circuit through that particular mux. So once circuit is established, when you have dialed a number and that subscriber has picked and the circuit is established, then there is a communication, and now you are sending some pulses. So pulse oriented, the billing information, other things can be taken over there. Otherwise, so circuit is established, communication. After whenever you keep your receiver, all the circuit, entire circuit is broken. If you are making such a kind of approach, so you require more connections required, more wiring and other kind of stuffs, because ultimately how many wires are running through the exchange and other stuff starts mattering. Individual homes, the ಪ್ರತಿಯೊಬ್ಬ subscriber ಗೆ. Imagine a LAN so that every packet flows through that, because it automatically carries the address of from whom it is coming and where it is going. So it is packet oriented. So wherever it is free, it yes knows its source and destinations. It is free to move to take any path, because it is very well or aware of the destination. So it takes the help of the nodes. So then reaches the other end. What is the advantage? So point to point communications or links, whenever you are thinking of that aspect. So if I say that there are n people, and so maybe that's a slightly yes. So number of wire segments increases if exponentially with number of units. If I want to establish communication between n people or n systems for that matter, these many wires are required to make a point to point communication, which is costlier affair. As well as whenever something is not working, you have to debug that entire mesh of wires. So that is again a reliability or maintainability aspect comes into picture. um, that is with respect to point network. So switched circuit switch network bandwidth is reserved for based on the peak bandwidth requirements for an application. This is not effective for applications that are inherently bursty in nature. So traffic can come anywhere, or if you are using a landline more oftenly, so you see that there are blocking maybe in the evening times or the morning 9 to 10. That's when telephone exchanges experience more load compared to the other parts of the day. And there is some reservation for the emergency calls or the peak bandwidth, the requirements or hotline kind of stuff. So you are wasting certain kind of bandwidth that may not be suitable for real-time applications. So real-time applications are bursty in nature. So bursty in nature, as we stated an example of fire alarm, it may never be producing any stuff, but whenever there is a fire, it has detected. Maybe that time it is generating enormous amount of information simultaneously to reach the different ends. So it may be you may want to communicate to police, you may want to communicate to ambulance, you may want to communicate to the fire brigade, and you may switch on to the sprinkler and any other fire extinguisher mechanisms. You have to announce it. So within a small span of time, so many information or so many computation has to be generated. That's where otherwise it is as good as um, you are not addressing the emergency of a situations. Fine. Okay. So with respect to that aspect, there are different networks that are being proposed for the real-time systems. So CAN protocol or control area network was proposed by Bosch, the most oftenly targeting automobile industry. We will be discussing about that. Maybe you will be studying more in your automotive electronics rather than the RTOS. We are just touching it superficially, stating that there are different nodes, they are addressable, and you are sharing a common bus at certain bandwidth. And yes, you are less prone to noise compared to other bus standards. So LAN, local area network, most oftenly 802.3 or the IEEE 802.3 Ethernet protocols. So most of the communications currently is happening through that, other than the fiber ಬರ್ತಾ ಇದೆ, but later initially it's a 100 Mbps of the large distance communications are normally happening through LAN. Internet is a such aspect of many LANs together will make a internet. I think we'll stop it here. So anyway, I have to take up CAN. Okay, any doubts? Please post it onto the uh, classroom. So can leave the classroom. 1 minute. I will just take an attendance. So okay.